most probably today we should be able to wrap up this subject, and today our discussion would be on fair amount of buoyant force. We have understood when a object is submerged fully or partially in water, or not water, any fluid, rather we are talking about liquid, this object experiences an upthrust, and that upthrust is known as buoyant force. Today what we will do, we'll talk about something called Archimedes principle, and whole class will be discussing only Archimedes principle. Archimedes principle. And Archimedes principle will give us our answers to all our queries. All our queries means it will be addressing us. Number one, it will address us. It will address us about buoyant force. ठीक है, उस दिन सिर्फ आपको थोड़ा सा I just give you a logical outlook. This will make you understand everything. So it will answer us about buoyant force. Okay. Then it will be answering us about the mathematical value. Everything will get value. It will answer us. We have to cover all these things today. It will answer us about Archimedes principle, buoyant force, mathematical value. Then it will also tell us about apparent weight loss. Apparent weight loss. And it will also answer something called the density criteria, which we talk about. ठीक है, तो पहले एक एक करके समझते हैं, right? We'll understand everything. Let me get one marker also by that time. Sorry. Right. So, 4 things we will be answering today, and it's really interesting from here. So, Archimedes, another Greek philosopher back in BC period. So, the story goes something like that. Archimedes was actually swimming in his, or rather lying down in his bathtub, and they say that he was lying down without any clothes, and then he suddenly ran out of the bathtub shouting eureka, 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 means I have found it, I have found it, I have found it. So what he has found out, let us first try to understand Archimedes principle. So Archimedes principle says, let's understand the principle. Okay, लिखता भी हूं. So it says, when an object, आप लिख सकते हैं, when an object is submerged, when an object is submerged wholly or partially, there are 2 criteria. Is there any test in Phoenix Green tomorrow? Huh? That's why Arab is absent. That's it. I totally don't understand skipping classes for test. So, when an object is immersed fully, he may not be the reason, but maybe majority of the reason is that only. So we say when an object is immersed, partially or fully, these are fully immersed, okay? The object experiences an upthrust, that we also know. The object experiences an upthrust. यहाँ तक तो सबको पता है, right? The object experiences an upthrust, and write in bracket buoyant force. Now from here Archimedes principle starts getting interesting. So when an object is submerged partially or fully, these 2 cases are fully submerged, it experiences an upthrust. Bracket में लिख लीजिए buoyant force. उसी upthrust को हम क्या बोलते हैं? Buoyant force. Now, as I told you, Archimedes principle should first address me about buoyant force. So buoyant force का definition आपको मिल चुका है. This is first part of the, but the principle is not yet done. Now we should get the mathematical value, which is equal to which means what? The upthrust. What do I mean by the word which? समझ के लिखो. Which का मतलब क्या है? The upthrust, okay? Which is equal to weight of the, यहां पे थोड़ा सा टंग ट्विस्टर जैसा है, weight of the volume of liquid. Weight of the volume of liquid. I'll tell you everything, don't worry.
Also, is the convert volume into mass.
Weight of the volume of the liquid displaced by the body. Weight of the volume of the liquid displaced by the body, comma, and this upthrust. अब कहां से एक्ट होता है वो भी, see, upthrust is a force. You give the magnitude of the force, और डायरेक्शन भी देना ना, and this upthrust acts through the center of gravity of the submerged portion of the body. You first write. We cannot do two tasks at a time. And this upthrust acts through the center of gravity of the submerged portion of the body. ठीक है? यहां लिख लेने के बाद आराम से पेन छोड़ दीजिएगा और समझिएगा. So when a body is immersed partially or fully, see how I am remembering, it's not I have mugged it up. If you observe my definition, every time some words are getting changed. But I have understood the principle. That's why it's easy for me to say. When an object is submerged partially or fully in a liquid, the object experiences an upthrust, bracket buoyant force. And that is the definition of buoyant force. And this upthrust is equal to weight of the volume of the liquid displaced by the body and acts through the center of gravity of the submerged portion of the body. ठीक है? अब दो फर्स्ट पार्ट जो buoyant force है, इसको तो हमने बहुत बार पढ़ लिया है, कुछ समझने की जरूरत नहीं है. ठीक है ना? ये buoyant force क्या होता है? This is equal to the upthrust. ठीक है? और ये upthrust कब पैदा होता है? जब आपका होगा submerged, है ना? कैसा submerged? Partially और फुल्ली. ये पार्ट तो हमें समझ में आ गया है लास्ट क्लास से भी. अब यहां की बात करते हैं. नाउ fill a bathtub fully with water. Fill a bathtub fully with water. Fully fill the bathtub fully. तो आरब ज्वाइन किया है. ठीक है? क्या रे, तू इंग्लिश टेस्ट के लिए पढ़ रहा है क्या? देखो मुंह, क्या हेडेक था? हेडेक इधर आ जाते, इधर कितनी बातें होती है, सारी हेडेक कम हो जाता है. सो अभी क्या करते हैं, एक बाथटब लेते हैं. उस बाथटब नहीं, समझ लो एक ग्लास ले लो. टेक अ ग्लास एंड फिल इट टिल द ब्रिम विथ वाटर एंड पुट अ पोटैटो इनसाइड इट. Will water come out? Right? Don't let that water spill off. Measure that water. That is called volume of water displaced by the body. When you go inside a bathtub, you are making space for yourself. Was the bathtub empty? No, it was filled with water. So someone has to make space for you, right? Who is making space for you? Water is making space for you. So when I get inside the bathtub, which is fully with water, the water spills out of the bathtub. And imagine I have got a mechanism in which all the water falls on another bathtub. Bathtub के अंदर एक bathtub, and I can measure that volume. Have you understood? That is called volume of displaced fluid. Did you understand? जब हम in Indian Navy and in other merchant ships, when we say about big class ships, frigate class, corvette class ships, destroyer class, so you will always see a ship will be defined by its displacement. मतलब वो ship जब पानी में जाता है ना, कितना पानी डिस्प्लेस कर देता है. Have you understood this particular thing? Now let's see the second part of the law. Once again, it says, the second part says that this upthrust is equal to weight. Now upthrust क्या होता है बेटा? Upthrust एक force होता है कि नहीं? Right? Weight भी तो एक force ही होता है. Means Archimedes is connecting force with force. No issues. No issues so far. Okay. This upthrust is equal to weight of volume of liquid displaced by the body. That means please measure the volume that is getting out. Measured? Take that volume and now measure its weight. that weight is equal to the upthrust. Are you understanding the funda? So we have taken a tumbler filled with water, and what we have done, we have put a aloo inside it. Aloo experiences an upthrust, so aloo must have displaced some liquid, and the liquid has fallen off. Measure that liquid, that volume, and now we'll see mathematically. If you measure that liquid's volume, that volume's weight, उसका weight और ये अपथ्रस्ट दोनों क्या हो जाएगा? इक्वल हो जाएगा. समझ में आ रहा है? ठीक है? Now start going for our stories for each of these criteria. This is a case where we are saying this is case number 1, and case 1 is a float. Agreed? Case 2 is fully immersed and floating. ठीक है? Case 2. Case 3 is submerged. ठीक है? तीनों केसों में क्या क्या था आप याद कीजिएगा. ठीक है? कैसा था हमारा? In this case we said, how does the weight act? The weight always acts from the center of gravity of the body, center of the body. So this is the weight of the body. Here also this is the weight of the body, W, and this is also the weight of the body, W. Agreed? Clear? Here the body is floating. That means इतना पोर्शन पानी के नीचे गया है ना? इसका जो सेंटर है यहां से buoyant force एक्ट कर रहा है, and this is say buoyant force FB, and in this case FB must be greater than W. That's the reason the body is floating. वरना the body नीचे चला जाता. In this case, this much of the portion has gone inside. So the submerged portion center of gravity. So it will be the same center. So this is FB. In this case, FB is equal to W. Have you understood? That's why they are holding. And in this case also, this is the submerged portion का center. तो यहाँ क्या हो गया? यहाँ भी FB आएगा और यहाँ FB will be less than W. ये केस समझ में आया? FB will be less than W. ये तीनों समझ में आ गया? Right. Now say. Now imagine one thing. Okay. Now I said the mechanical value should come. So let's go for the mechanical value. Okay. Now there is also something called apparent weight loss. Weight loss. So let's attack at this weight loss part first. When you get inside water, you feel that you have lost weight. And you feel the loss of weight till some portion of your body is inside the water. As soon as that portion of body gets out of water, you again feel that आपका तो weight पूरा आ चुका है. ठीक है ना? अब जो पोर्शन अंदर गया है, ठीक है, ये पोर्शन अंदर गया है, तो इस पोर्शन का ये इसी को तो buoyant force कैंसिल कर रहा है. Right now, this body is, what is the actual weight of the body? W. Actual weight of the body is W. Or right now,
W minus U.
So actual weight of the body is W. What will be the weight loss? Apparent weight of this body? The apparent weight of this body will be W minus FB, because FB is taking care of that hash portion of the body. ये clear हो रहा है? FB is nullifying that. So आपको ये body हल्का लगेगा. कितना लगेगा? FB minus W, because FB is winning. Are you understanding? So let's take it. Let's say the buoyant force is greater. This is case number 1. Float. The buoyant force is greater than W. Do you agree? The buoyant force is greater than W. बात सही है, ठीक है ना? अब buoyant force को किसके साथ equal किया है? The buoyant force has been made equal to the weight of the volume of liquid displaced by the body, right? So let us understand one thing now. How much of volume does a body displace? A body displaces volume equal to its volume only, na? Say suppose I ask you what is the volume of a sphere. You say pi r, 4/3 pi r cube. I said what is the volume of a potato? उसका तो कोई formula नहीं है. How will you find out the volume of a potato? You'll say, sir, get one measuring cylinder, fill it with 50 cc, 50 centimeter cube of water, and then put the aloo inside it. Water rises up, and say water rose up till 75 centimeter cube. So what is the volume of the potato? 25 centimeter cube. Potato went inside, and that much volume of water came outside. Are we fine on that? So whatever should be this volume of fluid displaced, isn't it not equal to volume of the portion submerged of the body? Try and think, हाँ, जबरदस्ती नहीं समझने का. The volume of fluid displaced should be equal to the volume of the body submerged, ना? So let us say that the volume of the fluid displaced अगर V है, then the volume of the, ये भी तो V होएगा, volume of the body submerged and volume of the fluid displaced, both are VV. Understood? This is volume, not volume of the whole body. Volume of the submerged portion of the body should be equal to volume of the fluid. You know volume. Now we want to find out weight of the volume of the liquid. अभी weight क्या होता है? Just common sense लगाते हैं. What is weight? Weight is mass multiplied by acceleration due to gravity. Somehow I should get its mass, right? So this is a fluid, and let's say this fluid has a density which is given by rho. Fluid की density क्या है? Rho. और ये body जिस item से बना हुआ है, it may be plastic, thermocol, whatever it is, its density is denoted by a symbol sigma. This is small sigma. जैसे आप capital sigma लिखते थे, just उल्टा 9 की तरह. This is small sigma. ये उसकी density है. Clear है दोनों? Right. अब यहाँ पे देखो. Now we are going to find out weight of volume of liquid displaced. Weight of volume of liquid displaced. How much volume did you displace? V. So density का definition क्या होता है बेटा? Density is always equal to mass upon volume. You want mass, so you should multiply density and volume. So how much volume did you displace? V. And what is the density? Rho. What is this item giving you, beta? Mass. This is your mass. Do you agree? But you need weight. So can we multiply it with G?
Yeah.
Weight हो गया? Clear?
Yes.
Any doubt out here? We displaced V volume of liquid. V volume of liquid, when we looked for its mass, it is V into rho. This is the mass. Mass multiplied by G gives me the weight. ठीक है ना? तो अभी यहाँ पे हम क्या करते हैं? Let us say the buoyant force. तो buoyant force हमारा कितना हो गया? In first case, the buoyant force is equal to V into rho into G. ये clear हुआ कि नहीं? ये Archimedes principle बोलता है. What is the mathematical value? The mathematical value is always given by the volume of the liquid displaced multiplied by the density of the liquid multiplied by acceleration due to gravity. So ये portion कितना है? ये portion हमें बताता है mass. और mass into G. Weight हो गया? Clear? No issues? तो इसको लिख के रख देते हैं V into rho into G. So if anybody asks you what is the formula for buoyant force? Buoyant force is always V rho G. What is V? V is the volume that the body displaces. आप अगर बाथटब में घुस गए, आपने जितना वॉल्यूम डिस्प्लेस किया वो है V. Rho is the whatever you are bathing on. If you are bathing in Rasna, then rho is the density of Rasna. If you are bathing on Campacola, then Campacola's density is rho. And G is acceleration due to gravity. Have you understood? Now, isn't the buoyant force also equal to the portion, the weight of the portion of the body that got submerged inside? It should be. You see what I'm saying? Have we understood the basic formula for buoyant force? No issues on that? Okay. You remember once I used to say a body floats only when its density is lighter than the density of the liquid on which it is floating. Right? अब वो चीज आएगा मजा से. This is the formula for buoyant force. It is given by volume of the fluid displaced multiplied by the density of the fluid multiplied by x. So this is a force. ये weight हो गया. This is the weight of the volume of fluid displaced. Clear? Now, question arises. Buoyant force is the one who is responsible for making this object feel light as it goes inside water. Why does this object feel light? Does it lose some mass? No, mass तो loss नहीं हो रहा है. So it is cancelling some portion of its weight. What portion of its weight does it cancel? Submerged portion's weight. Have you understood? Submerged portion's weight. अब इसका मतलब, this is what beta, this is buoyant force. This buoyant force should be also equal to weight of submerged पोर्शन ऑफ बॉडी। देखो बॉइंट फोर्स के दो तरह से आते हैं, एक होता है बॉइंट फोर्स इज इक्वल टू वेट ऑफ वॉल्यूम ऑफ लिक्विड डिस्प्लेस्ड plus should also be equal to weight of submerged portion of body. That's why we say a buoyant force has nothing to do with whether you are dipping iron or plastic. As long as the volume is same, buoyant force will be same. Why did I say that on that day? Because buoyant force depends upon the volume of liquid. सोचो आप एक 5 नंबर का फुटबॉल लेके आए और 5 नंबर का प्लास्टिक का बॉल लेके आए, दोनों का वॉल्यूम सेम है, so this V will be same. Both will displace the same amount of water, na? So buoyant force has nothing. This buoyant force has got damn nothing to do with the mass of the body that you are dipping in that liquid. It is only related to the volume of liquid that that body is displacing. आप मेरा बॉडी को डिस्प्लेस करो या मेरा मैनिक्विन प्लास्टिक में बना के डिस्प्लेस करो, as long as our volume is same, it will displace the same amount of water. डुबाना ही तो है उसको, ठीक है? अब यहां पे देखते हैं, so this is one way you are connecting buoyant force. Another way is this buoyant force is also equal to the weight of the because this buoyant force is making you feel light. Apparently what was the weight of this body? W. How much is the weight now? Fb minus W, है ना? अब weight of the submerged portion of the body निकालते हैं फिर से, तो इसका weight कैसे निकालेंगे? इसका वॉल्यूम भी तो V होगा ना, V वॉल्यूम displaces V वॉल्यूम। अब ये वाला डेंसिटी लगाते हैं, तो इस बॉडी का ये वाला मास कितना होगा? डेंसिटी इनटू वॉल्यूम। बट व्हाट डेंसिटी? बॉडीज डेंसिटी। बॉडी जिस मटेरियल से बना है मींस इनटू सिग्मा इनटू जी। बॉडीज डेंसिटी, इट इज द बॉडीज वेट ना, बॉडीज वेट, सो बॉडीज डेंसिटी। अंडरस्टूड? सो buoyant force is always equal to the volume of liquid that is displaced, also equal to weight of the submerged portion of the body. Now let's see case number 1. In case 1 we are floating, yes or no? Floating, so we can't say this is equal. buoyant force बढ़ रहा है, weight of the body से ज्यादा है, ठीक है ना? तो इसमें क्या करेंगे? G ने G को काट लिया, V ने V को काट लिया, rho should be greater than G. This is the sigma. This is the criteria of flotation. Rather we write it like this: sigma should be less than G. The object whom you want to float should always have density less than the fluid on which you want it to float. So it says that if there was some Hanuman who could have brought Uranus. Uranus is a planet made of gases. Uranus's density is less than the density of water. और सो यूरेनस को लेके इधर पिरमचरू लेक में फेंक देता तो यूरेनस फ्लोट करता। सुनने में अजीब लगता है, but that's true. Uranus would float on water. Uranus is very bigger than Earth, sir. But Uranus as a planet, his density is of all gases, less than that of water. So in order for any body to float, the density of the body should be less than the density of the liquid on which it is floating. Now we'll come to this. Now here also we'll have controversy that iron's density is more than water. Still iron ship is not sinking in water, ठीक है ना? उसका डेंसिटी ज्यादा है। ऐसे भी आप कोई भी चीज ले लो, take anything whose density is less. If you take the density less, then it will always float on water, ठीक है? पहला केस समझ में आया। This particular case where it will just hold, case number 2, it will just hold or float fully submerged. In this case, what we are finding, this is a little bit advanced than what you study, but still I think you should like it. Here V rho G, that is the buoyant force, should be equal to the weight. So V rho G should be equal to V sigma G. G cancel, V cancel, density is equal to this. If there is any body whose density is equal to the density of the fluid, अब यहां पे एक बात आता है, वो धीरे बताऊंगा, तो आपका बॉडी क्या करेगा? फ्लोट करना शुरू कर देगा, एकदम डूब जाएगा लेकिन जस्ट फ्लोट करता रहेगा, गिरेगा नहीं, नीचे नहीं जाएगा। एंड द थर्ड केस वाज व्हाट? सबमर्ज्ड, ड्राउन जो आपका है ना। सो ड्राउन होने के लिए बाय नाउ यू नो FB should be less than what? W. So V rho G should be less than V sigma G. So V gone, gg gone, rho should be लेस देन सिग्मा, मतलब भारी चीज को पतले फ्लूइड में डाल दो। केरोसिन इज वेरी लाइट, उसमें आप भारी चीज डाल दो, डूब जाएगा ससुर। समझ में आया? लेकिन यहाँ ये क्राइटेरिया को लिख लीजिए। सो वी हैव एड्रेस बॉयंट फोर्स, we have addressed mathematical. What does the mathematical value tell us? Two type of problems we may get. One is calculate buoyant force. How? By this Archimedes straight principle. Buoyant force is always equal to weight of the volume of the liquid displaced by the body. Another way to calculate buoyant force is what? It is also equal to the weight of the submerged portion of the body. जितना डूबा है, जितना डूबा है, इन दोनों केस में देखो, ये ग्रेटर आया, ये वाले केस में लेस आया। प्रॉब्लम करना है तो इक्वल वाला केस लेना पड़ेगा। इक्वल केस इज दिस वन, वेयर इट इज इक्वल, जस्ट सबमर्ज हो गया है, ठीक है। हियर देयर विल बी अ नेट फोर्स। व्हाट इज द नेट फोर्स हियर? W minus FB. This is the net force here. And since net force, there will be acceleration. Body टर्रक करके नीचे चला जाएगा। Now question arises, so have we understand buoyant force? Have we understood the mathematical value? Now comes apparent weight loss. That also we have addressed. What is the apparent weight loss? The apparent weight loss is given by, simply to understand, buoyant force should be equal to the weight of submerged portion. अगर पूरा डूब गया तो पूरा। अब एक बात आता है उसमें, सर buoyant force इस केस में सबमर्ज्ड पोर्शन के ऊपर डिपेंड कर रहा है, या हमने ज्यादा डुबो दिया तो ज्यादा buoyant force आया। यहां और यहां के buoyant force में कोई डिफरेंस नहीं आएगा। buoyant force is a limiting force. After you fully submerge the body, you can't expect new buoyant force to increase or decrease, because buoyant force depends upon volume of liquid displaced by the body. Since you have fully submerged it, अब और नया पानी कहां से डिस्प्लेस होगा? होएगा ही नहीं। अब वो बात समझ में आ रहा है? फिर से एक बार देखो, यहां पे मैं इस बॉडी को और डुबो सकता हूं तो और ज्यादा पानी बाहर जा सकता है, तो buoyant फोर्स बढ़ता जाएगा। यही आप स्विमिंग पूल में जब दोनों हाथों को और नीचे ले जाते हैं तो लगता है नीचे का राक्षस और धकेल रहा है हमको। एक बार पूरा चले गए, there is nothing more left in my body to get submerged. So the maximum volume that I could displace, I have displaced. Buoyant force is now at its limit, uppermost limit. इसके बाद अगर आपका weight बढ़ा, now you will go down. And when you go down, your buoyant force is less than the weight. So there is a net force now acting. The net force is the excess of weight. And whenever there is a net force, there is acceleration. Newton कहता है जब net force है तो acceleration है। Uniform motion नहीं होगा, body rapidly अंदर जाएगा। इसीलिए जब टाइटैनिक डूबा, डूबते तक टाइम लग रहा है, because buoyant force is pushing Titanic. एक बार पूरा डूब गया, then it took it just 4 to 5 minutes to go and travel 11 kilometers down the Atlantic. चला गया नीचे. It is going with an acceleration. Now the question arises, this one is something that our heart doesn't agree when we see a ship. What did we understand? From here we understood that if there is, ये मिटा सकता हूँ, can I rub this?
Could you tell what V was the land?
V is the wall. Fill one glass full of water, bring a potato, dip the potato in the glass, water will spill out, collect that water, measure its volume, that is V. V is the volume displaced. Don't try to copy the English out here. Try to understand, then you'll automatically get to know it. V is the volume of liquid displaced by the body. When you get inside a bathtub, that's a very common experience when you go to a hotel and all. पैसा दिए तो आज bathtub में भी नहाएंगे, पूरा पानी भर लेते हो बेवकूफ की तरह, and then when you get inside the bathtub, बसरास पूरा पानी, and whoever is outside the room says, "Hey, क्या कर रहे हो? पानी आ रहा है रूम के अंदर." आप आर्किमिडीज नहीं थे, इसलिए बाहर पानी आ गया। So what should you do? Fill the bathtub only, not fully, half. Then go and do one trial dippy. You don't know how much is your volume. सर मैं जाते ही पानी ऊपर आ गया, बस sufficient, और भरने की जरूरत नहीं है। Because if you are making your space inside the water, water has to come out of it, ना? या तो bathtub में आप रहोगे या पानी रहेगा, दो में से। Clear? ठीक है, हाँ बोलिए। There can be a lot of doubts here. Let's address and then we go further. Buoyant force depends on
density also.
हाँ, डेंसिटी पे भी डिपेंड करेगा. That's why we tend to say, suppose I'm asking you to swim on river water and I'm asking you to swim on sea water. Sea water is more dense. Sea में आप अच्छा swim करोगे, river में कम अच्छा swim नहीं करोगे. Sea water के and sea water में थोड़ा सा और condensed milk डाल देते हैं, milk maid, और गाढ़ा कर देते हैं. So if there is a cow dung slurry, you will swim even better on that. हाँ, फिजिक्स लगा के सोचो, cow dung और गाढ़ा होता है ना, उसमें और अच्छा swim होगा. ठीक है, इसको मिटाएं अभी धीरे धीरे, इस चीज को मिटाऊं बच्चा लोग. कैन आई रबी दिस? ओके, राइट. सो ask yourself 2-3 questions as I'm writing some points now, and if you have still not understood, no issues, ask me, I'll explain again. Number 1, have you understood what is CHI भी लिखते हैं कहाँ? जस्ट मेडिस. कोई कोई ARCHEMEDI इसमें, हाँ, CH Archimedes principle. Ask yourself, have you understood what is Archimedes principle? Archimedes principle होने के लिए you need a body and a fluid. फिर उस बॉडी को उस फ्लूइड में डुबो, या तो पूरा या आंशिक, fully or partially. Then that body starts receiving a upthrust. That upthrust is known as buoyancy. कहां से एक्ट करता है? Center of gravity of the submerged portion of the body. और कितना होता है? Mathematically will be equal to weight of the volume of the fluid displaced by the body. And volume displaced by the body, volume of fluid displaced by the body should be equal to volume of submerged portion of the body. मैंने अपने हाथ को सिर्फ रिस्ट तक डुबोया, कितना पानी बाहर आया? The volume which is equal to the volume of till this much. मैंने पूरा हाथ डुबो दिया, कितना पानी बाहर आया? The volume which is equal to the volume of my arm. मैं पूरा डूब गया, volume of my whole body. Can now I increase the volume any further? No, पूरा ही तो डूब गया, और कितना डूबू? अंडरस्टूड? उस वॉल्यूम का वेट, तो वॉल्यूम और वेट को कनेक्ट करने के लिए हमें क्या चाहिए? वेट इज ऑलवेज मास इनटू ग्रेविटी. सो इन ऑर्डर टू अंडरस्टैंड वेट, फर्स्ट यू नीड इज मास, एंड मास और वॉल्यूम को कनेक्ट करता है डेंसिटी. सो नेवर फॉरगेट डेंसिटीज डेफिनेशन. डेंसिटी इज ऑलवेज इक्वल टू मास अपॉन वॉल्यूम. मास अपॉन वॉल्यूम. Even the gas bill that you are getting in your house, the gas meter is recording volume of LPG used by you. So go and see the utility bill. In your utility bill, you will have something like this: closing meter reading CMR, opening meter reading. If you take the difference, this is your gas consumed. Do you understand? This is your gas consumed. Closing meter reading, ये महीना हमने 1000 में क्लोज किया, ओपनिंग हुआ था 900 में. How much gas did we consume? 100 units as per the meter. But LPG is sold in kg. So 100 units, this is units. This has to be first converted to meter cube. So the meter company will give you a conversion factor. Multiply with that, you get the meter cube of gas you consumed. But the society will bill you in terms of kg, because LPG cylinders are sold as per kg. One cylinder of LPG is 14.2 kg, which you get in the market. जो 1000 रुपए का सिलेंडर होता है, उसमें 14.2 kg गैस रहता है. So now we have to bill you in terms of kg. So what is the connect? The connect is density of LPG is equal to mass into volume. You need the mass. So volume or density. So density of LPG के साथ दोबारा मल्टीप्लाई होगा, तब जाके आपका consumption in kg आएगा, and then multiplied by the rate that government has for LPG. That is what you pay. So if you actually see, like my gas bill comes around 660, 700. My consumption is around 3 to 4 units. 4 units means 4 units in the meter. With that, I should get how much cubic meter? 10 with density, then you get it. Have you understood? Okay. Many people don't know that small thing. There are posts in Facebook forum. What is this reading all about? All have passed engineering, huh? Yeah, there are posts. I can show you right now. People who work in very big companies, they are writing those posts. Guys, what is this? Guys, can anybody explain? That's what I say. पढ़ो तो ऐसे पढ़ो कि आप चीज को समझ सको. ऐसे पढ़ के क्या फायदा? गैस का बिल ही समझ में नहीं आता है आपको. Engineer. Okay. So density. Have you understood Archimedes principle? Now let's see the condition of float, sink, and say float with submerged. So one of the condition, all these conditions in terms of density, we will see. And here we are saying, writing two up, I think. Okay. In terms of density, we will see this relation. And density means the density of the liquid is given by rho. The density of the body is given by sigma. If you want to float, then sigma should be less than rho. If you want to sink, then sigma should be greater than rho. If you want to float with submerged 100%, sigma should be equal to rho. We'll analyze this case just to understand a bit. It says that in order to float, your density should be less than that of the liquid on which आप तैरना चाहते हो. तो ये केस को देखते हैं. आयरन का एक नेल अगर हम बाल्टी के पानी में छोड़े तो आयरन का नेल तो टपक नीचे चला जाएगा. Obviously, iron's density is much more than that of water. I told you water's density is 1000 kg per meter cube, or water's density is 1 gram per centimeter cube. Mercury's density is 13.6 kg per meter. Mercury is very dense. So on mercury is like खीर. मर्क्यूरी के ऊपर अगर आप आयरन नील गिरा दोगे ना, वो आराम से फ्लोट करता है, पर हमारे इसमें फ्लोट नहीं करेगा. ठीक है ना. अब यहां से सवाल आता है, सर आयरन तो वाटर से ज्यादा डेंस है, फिर वो शिप कैसे फ्लोट कर रहा है? व्हाट इज द कंडीशन? फिर वो शिप कैसे फ्लोट कर रहा है? अब बात आता है यहां इस रिलेशन के ऊपर खेला जाता है. दे फूल यू ऑन दिस रिलेशन. व्हाट दे विल डू, I have to bring down the density. See, in order to float, end of the day, the density has to be less. So how can you reduce the density of iron? Jack up the volume. Density नीचे उतरेगा ही उतरेगा. Let's take one aluminum coin. Right? 8 में क्या पढ़ा था? Aluminum is malleable. मार मार के प्लेट बना सकते हैं. And let's go and hire a roller mill. Roller समझते ना? And put that coin between the roller. So coin becomes champ, पतला होते और aluminium उसको इतना पतला किया. डोलो 650 जब आप टैबलेट निकालते हैं ना, तो उसके पीछे फॉयल रहता है ना, उससे भी पतला कर दिया. That much of aluminum I have spread it over between me and Aditya. I have spread it. अब जरा कॉमन सेंस सोचो, इसको लेके हमारे स्विमिंग पूल में इस चद्दर को फेंक देंगे तो फ्लोट करेगा कि नहीं? 100%. The ship works on that principle only. The ship has lot of air space in between. नीचे of the ship is hollow. There's a lot of space. और उसमें air घुस जाता है. So the ship's volume becomes very high. So second question. I'm a big bulky man. I don't know how to swim. But when I put that inflated rubber tube, why do I float? The inflated rubber tube is what? Has a density less than that of water. So if I throw the rubber tube like this also, it floats. Now I have worn the rubber tube till my armpits, ऐसे. Now the rubber tube wants to go down with me. But the rubber tube can't go down. उसका density बहुत कम है ना, उसको बहुत जोर से buoyant force लग रहा है. And that buoyant force is taking care of my weight also, because I am clinging on the rubber tube. That's why you're floating. That's my simple funda. Have you understood this? Anyone who takes water inside, air लेके हल्का हो जाता है. आप नीचे breathe नहीं कर सकते हो. See, in swimming pools, when you first learn swimming, some things might be very common. They'll ask you to put your head in, move inside. जैसे move inside करके आपको बोलेगा सांस मत लो. जैसे ही आप सांस छोड़ दोगे ना, बक 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 बक, water goes out. आपने water inhale किया, your body automatically starts going down. Have you felt that in swimming pool or not? जैसे ही आप मुंह के अंदर पानी छोड़ दोगे ना, हवा छोड़, but after some time you can't stay more. You're locking out on your breath. Have you felt that? Go inside a swimming pool and just become horizontal like this, upside down, and put your head down. So for example, I don't know to swim that good. I can only float. I can save you. And I know floating very nicely. The only thing I enjoy in swimming pool is go down, become upside down, and don't hold any bar. I don't hold any bar. And be absolutely silent. Don't do anything. Put your head inside. And both the hands on there. You will fully float. So much that if you are holding a bar and you release it, you'll slowly come out of the bar. The moment you take out your head or the moment you release air, आपका body पक 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 नीचे चला जाए. That's for the reason to the way we swim is always your head should not go down. How do you swim? You swim with your मुंह ऊपर रहना चाहिए. Like this. हाथ ऊपर, like a crocodile you drag water and आपका मुंह ऊपर रहता है, मुंह कभी नीचे नहीं जा सकता. That's just how you breathe. This is the water surface. Your mouth should be always like this, like this, like this, like that. मुंह नीचे जाएगा, नाक मुंह में पानी के खांस क्या हो गया आप बाहर. ठीक है? Understood? That's all about flotation. That's all about what you learn in grade 9. So what is Archimedes principle? Many books will write Archimedes principle in many ways. First, somebody may write only a truncated portion. Volume of fluid displaced by the body is equal to volume of submerged portion of the body. Is it true? Yes, true. A part of Archimedes principle. Then the buoyant force exerted on a body is equal to the weight of the body, portion of the body submerged in the liquid. Is that Archimedes principle? Well, a portion of Archimedes principle. So what does Archimedes principle say? Whenever a body is immersed fully or partially in a liquid, the body experiences an upthrust known as buoyant force, which acts through the center of gravity of the submerged portion of the liquid and is mathematically equal to the weight of the volume of fluid displaced by the body. And that volume will also be equal to volume of the submerged portion, because एक fluid उतना ही निकलेगा जितना body का volume होगा. And there are 3 different criteria where sometimes buoyant force is winning over buoyant forces. So if anybody asks me what is exactly buoyant force, I would say buoyant force is always V rho g or rho Vg. Rho Vg. Rho is density of the fluid. V is what? V is the volume of fluid displaced. And what is G? G is acceleration due to gravity. Rho Vg should be equal to sigma Vg. Vv same, Gg same. So rho equal to sigma. This is the criteria. Yeah.
Like when you're measuring density, when the object is floating, so some part is still submerged. So you calculate the density on the basis of the center of the object.
Density of the material. आप कैसे भी लो, density same ही रहेगा. Density कभी change नहीं हो जाता है. Density, that's why density is a material specific measurement, not geometry specific measurement. The density of water is 1000 kg per meter cube, whether you bring 1 drum of water or 1 drop of water.
So density is mass by volume. So
Density's ratio is mass by volume. To get that 1000, do you understand this and this? Both are having water. Understood? This is also water's drop. इसका density same है, 1 kg per meter cube. अगर आप यहाँ ये ratio, sorry, not 1 kg, 1000 kg per meter cube. If you want that ratio to be valid here the mass is more, so obviously the volume also has to be tweaked such that you get how much? 1 only. Density is a material specific measurement, na? It has nothing to do with geometry. Density is density.
yes.
हम ये नहीं बोलते हैं डेंसिटी ऑफ मिल्क, सर 1 ड्रम मिल्क का डेंसिटी क्या है, बोले बेवकूफ लड़का है. Density is material specific. That's why you look at the LPG consumption of your house. Density of LPG we are multiplying. You may consume for only 2 rotis. We have a cloud kitchen. We consume more gas, but density is material specific. It's LPG specific. Nothing to do with how much you consume, how much I consume. ठीक है? Ready to do some problems कर सकते हैं अभी, if this is fine. Any questions? I mean, I'll wait for any questions. Anything? Anybody joined late, not understood? कोई भी सवाल पूछना है पूछ सकते हैं यहाँ से. If you decrease the mass density decrease, density तो उतना ही रहेगा. आपका mass decrease उस ratio में होगा तो volume change होता जाएगा. Blah blah by blah blah is equal to tlatla. तो अगर आप इसको छेड़ देते हो, ये कांस्टेंट ही रहेगा, ये ऑटोमेटिक छिड़ जाएगा. समझ में आ रहा है? Anyone who has not understood anything out here, anything related to flotation, buoyancy, ठीक है? In fact, there is later we study what is absolute density, what is relative density. Those are also there, but now those have been taken off. So density. Absolute density is this, water's density. Relative density is density of a fluid with respect to another fluid. What is your absolute strength? What is your absolute strength? Sir, 500 newtons. His strength is 250 newtons. Yatharth. So what is your relative strength to him? Twice. Twice. Then your relative strength is 2 Newton only. 2 Newton. Because if you make him 1 Newton, 2 Newton. That is relative. Okay. Anyone has Lakshmi Singh or any other book? Usme kuch? I didn't bring. Okay, let me get my copy then. Let's do some problems. Let's see. We have time. Next chapter we will go is work, energy, power, and then sound. Okay. Here there used to be relative density once upon a time. ये तो सब हटा दिया. Okay, let's do some common. Let's take some data and do a problem. So you can write down the data. The volume, just write down the volume of a solid. You can write down the data na, given. Volume V is equal to 350 centimeter cube. ओए, given के बाद volume लिख, खाली V लिखा है. मेरी आंख यहाँ तक जाती है. Volume V is equal to, it can become velocity also, right? Then write mass M is equal to 500 grams. Mass M is equal to, करते क्या हो इतना देर? आओ लिखो, given volume V, mass M, कितना है? 500 ग्राम. Volume is 350 ना? 350 centimeter cube. ठीक है ना? तो सब मजेदार है. Okay, that much data is given. What is the density of this solid? First you calculate what is the density. Density SI unit में kg per meter cube होता है या फिर आप ग्राम पर सेंटीमीटर क्यूब में भी दे सकते हैं.
So V into volume into rho is equal to.
So density is, say, you take rho or sigma, whatever, should be equal to mass upon volume. 500 divided by 350 है ना? Grams per centimeter cube. Roughly, I am taking this problem like this. That this density is greater than 1 gram per centimeter cube. Why did I write like this? Mani man में ऊपर 500 नीचे 350 ना? So this ratio should be more than 1. Yes or no? Why did I write like this? क्या कारण है? ऐसा क्यों लिखा? I didn't write the answer. You must have. मैंने ऐसे क्यों लिख के रख लिया है? Water's density is 1 gram per centimeter cube. Yeah. And this one's density is coming how much? More than. यहाँ देखो ना, more than. So अगर अगला क्वेश्चन फ्लोट सिंक है तो स्टेट आंसर कर सकते हैं. Are you getting it?
Yes.
इतना डाउट क्यों होता है अंगद? एक चीज को एक बार समझने में प्रॉब्लम क्या है? इतना डाउट क्यों है? Water's density is, if you are having so much doubt, practice it nicely, write it in front of your study table. Density of water 1000 kg per meter cube or 1 gram per centimeter cube. You are at 9. 9 is gone. Now you'll be in 10. In 11 you will be getting goddamn 16 constants. आप कहां से याद रखोगे फिर? क्यों याद नहीं हो रहा है? क्योंकि आप पढ़ते नहीं हो टाइमली. यहाँ आके आप लोगों को मजा आता है. आई अंडरस्टैंड, यू ऑल अंडरस्टैंड फिजिक्स, यू ऑल लव फिजिक्स, को मजा आता है, लेकिन आप उसको उतना प्यार नहीं करते हो, घर पे नहीं पढ़ते हो. अगर आप घर में पढ़ोगे तो वो डेटा इतना बार क्यों कंफ्यूजन हो रहा है? वाटर्स डेंसिटी कैन बी इन SI यूनिट, कैन बी इन CGS. नाउ वी आर डूइंग द प्रॉब्लम इन CGS यूनिट. 1 ग्राम पर सेंटीमीटर क्यूब. आप चेहरा देखिए, मैं समझ सकता हूँ आपके अंदर खलबली मचा हुआ है. नहीं था थोड़ी देर पहले जब वाटर की डेंसिटी. What you all are trying is, I'm saying, when you are going for a competitive exam and all, don't try to calculate the whole density unless and until requested or asked. Ultimately, ये chapter float sink के ऊपर है. मैंने ये park करके रखा. None of you all, because your facial expression will only give me whether you have understood the juice part of it. That's why I put a smiley. इसका density 1 से ज़्यादा है. If anybody asks the question, will it float or sink? They may not. I have my answer ready. I need not solve this ratio. Work smartly. Next part of the question. Anyways, you should have calculated what is the density. What will be the mass of water displaced by this solid? What will be the mass of water displaced by this solid? First, you should find out what is the volume of water displaced. Volume of H2O displaced should be equal to what?
Volume of this.
Volume of the body, which is equal to 350 cm cube. Now you want to find out mass of volume of H2O displaced. So bring the ratio. Mass is always equal to density of water multiplied by the volume of water. What is the density of water? 1 gram per centimeter cube into 350 centimeter cube. Centimeter cube ने centimeter cube को काटा. Answer आया 350 grams is the mass of that. Of the centimeter cube into gram. One is volume, one is mass. You can convert. Vaibhav, please bring acid from market and pour on my face. I will be more happy. Butter is sold in grams. Cloth is sold in centimeter. How can you convert one to the other? समझ में आया? Next सवाल. What will be? अच्छा, relative density छोड़ दो. Relative density is density of one fluid by the other. Anyways, that you have not studied. Will it float or sink in water? ये सब बता सकते. It will sink in water. Its density is more than that of water, so it will sink. क्या बच्चा बच्चा सवाल है. तो ICSE questions आना चाहिए. In fact, you know, ships keep on displacing water. If you have cargo ships on the tail of cargo ships or the aft side, you know, the hull, ship के case में हम hull बोलते हैं और bow बोलते हैं, stern and then on. The bow side में there will be some lines on the ship, paint किया हुआ रहता है. These are called plimsoll lines. So as you keep on loading the ship, वो line पानी के नीचे जाता है. एक level के बाद the captain will not take any more loads. See some lovely videos. There is a guy called Naresh Narvankar or somebody. He does beautiful YouTube videos of Antarctica expedition. I have watched all his videos. बेकार चीज देखने से something beautiful. You know where the ship goes from? It goes from Argentina. ओशिया करके एक जगह है. ब्यूनस आयर्स से प्लेन में ले जाता है और वहां से 48-hour journey. And they are costly trips. 5 lakh is the cost of the trip. So they'll take you to some of the harbors. Then there will be penguin. You can't go with any shoe wearing on Antarctica. You cannot bring any foreign thing. After the ship has got washing system, आपका boot wash हो जाएगा. Then temperature is 3 degree, -2 degree. Then they'll show how much degrees, 0 degree, कितना pole पे चले गए ना. Then there will be see. Then that fellow says now $45,000 is the cost to go to the Arctic Circle. हम तो नहीं जा पाएंगे. उसी के वहाँ पे देखो. Beautiful videos they make. Episode after episode, very nicely. And in boat, what they do, those are star class cruise ships. On your bed you'll have पूरा LCD रहेगा, उसमें सब बताते रहेगा आज इस टीम को कहाँ ले जाएगा. There will be quiz, this, that. So nice. चैनल ऐसे तो अंटार्कटिका क्रूज वो आ जाएगा. इंडियन एक है नरेश करके, नरेश या नवीन नारवंकर करके आएगा वो. He and one Sardar is there with him. Very nicely done video. And then they'll go to Antarctica. क्या क्या आप कर सकते हो, क्या नहीं कर सकते हो. Then what to eat, how giddy you feel, when the captain will ask you not to go. बढ़िया चीज है. देखो ना अच्छे. The whole YouTube. So you should, if you have interest, Anya, switch on the light in your room. If you have interest, you should see some things. If you love geography, go to YouTube and take videos. Type 8K. 8K 60 FPS means 60 frames, or 4K 60 frames. Helsinki. Helsinki means Finland. वहां पे वो those are what you call Scandinavian countries ना. You won't see night. Alaska के videos देखो. Time they will show you 1:30 a.m. Sun is shining bright. देखो ना कितना मजेदार चीजें हैं. ये सब यहाँ देखने को नहीं मिलेगा. Some regions of Russia, Sweden के videos देखो. What is the tax structure in Sweden? How does the government take care? What is the population? कितना सुंदर है. वो city, and there will be pin drop silence videos. Nobody is blubbering anything, but city noise and all in 4K, 8K. A country like Switzerland, heart of Europe, never went to any of the world wars. Sweden never went to any of the world wars. What is, if you want to migrate to Sweden, what is the criteria? What does the taxation structure say? कितने अच्छे videos है, देखो. I to say I don't need any connection. I just need one high-speed internet and one good television and YouTube Premium, so that बीच में वो सब नहीं आना चाहिए advert. बस ठीक है, चलिए. एक प्रॉब्लम किया जाए. है ही नहीं, वैसे छोटा छोटा प्रॉब्लम ही आता है. Okay, a piece of steel has a volume of 12 centimeter cube. Steel 12 centimeter cube, volume 12 centimeter cube, mass 96 grams. Calculate its density. Volume 12 centimeter cube, mass 96 grams. तुम यहां से यहां भी गलत सुनता है, 97 लिखता है. Calculate the density. This is CBSE problem. आप देखो यूनिट और सिंबल. यूनिट आप देखो, डेंसिटी का फॉर्मूला क्या है बोलो. केजी बाई मास का ऐसा यूनिट क्या है. मास का ऐसा यूनिट क्या है, केजी. वॉल्यूम का ऐसा यूनिट क्या है. इतना मैथ्स पे कर चुके हो, मीटर क्यूब. सो व्हाट इज द डेंसिटी, केजी पर मीटर क्यूब. और अगर केजी का छोटा भाई ले ले तो ग्राम, मीटर क्यूब का छोटा भाई ले ले तो सेंटीमीटर क्यूब. सो ग्राम पर सेंटीमीटर क्यूब, दैट इज नोन एज द CGS यूनिट. ठीक. एंड इफ यू गो बाय इंपेरियल और द ब्रिटिश, देन इट शुड बी मास इज पाउंड. Pound weight, pound mass, pound per inch cube, cubic inch, cubic inch. That is how the British will do it. Okay. These are all same problems you all can do. I mean, there is nothing great.
American also use inches, right? It's similar to the British.
Similar to the British. They'll go same. Kilometer, miles, furlongs. They go that way. Ounce, inch, but now everything goes on mm, right? So with this we conclude this chapter. I'll pass